All right, guys, this is the back side of the quiz review sheet. And again, I'm just going to do the odd problems with you to kind of help you get through it. All right, on number 11, it says it just wants us to simplify, meaning we need to go as far as we can. And the rules here are no negative exponents in the final answer and no roots in the denominator. So we'd have to rationalize if we come across that. And again, each one of these is different. I understand that we're not always sure where to start. A good thing to do is start with what you know. You know a power to a power, you multiply. You know like terms, you add the exponents. So follow those exponent rules that you have learned in previous courses and that you've reviewed in this course to help you make that first step. Usually that will give you enough to get the ball rolling so you can answer the total problem. And again, sorry for the terrible focusing. Y'all know the drill. It's just this camera, but you guys have the sheet in front of you. All right. When we have negative 1xy to the fifth, technically all of that is being raised to the fifth power. So we can either turn these all into exponents or turn them into radicals and reduce. Whichever way is fine as long as you don't have negative exponents and you don't have roots in the denominator. What I'm going to do is distribute the 5 to the negative 1, the x, and the y. So now what I have is negative 1 to the fifth power, x to the fifth power, y to the fifth power, times x to the negative 4, y to the negative 4. Now we know negative 1 to the fifth power is just going to be negative 1, so I'm going to just write a negative out front. And then what I'm looking for is if I am multiplying like bases, so x with x and y with y, I know I just add the exponents. So if x to the fifth times x to the negative fourth means I add the exponents, 5 minus 4 is just 1. So that becomes x to the first. Same thing with y. Y to the fifth times y to the negative fourth just becomes y to the first, so just y. So my final answer there is just negative xy. Looked way harder than it ended up being. And again, just take that first step of power to a power you multiply, or multiplying like bases, you add the exponents. All right, something like 13, again, power to a power we multiply. So that becomes y to the 10th. Power to a power we multiply. Don't forget also that this might be an outside-in question or an inside-out question. It just depends on your preference. So one thing we could have done here is said negative 1 to the negative 1, or sorry, multiply that. So negative 1 times negative 1. Or we could have done negative 1 to the x power. So what that means there is I would have a fraction because I have a negative. What I'm going to do is go ahead and multiply the two exponents because technically the negative 1 right there has an exponent of 1. So I'm going to distribute the 3 and go from an outside-in approach. So if I have negative 1 and I raise it to the third power, there's the negative. And then with the x, I'm going to get it x to the negative third power. Well, I know negative 1 to the third is just negative 1, and x to the negative third, I can't have a negative. Technically, it's over 1, so I'm going to have to flip the fraction to the bottom. So my negative 1 is going to remain on the top. I also have y to the 10th on the top, but my x to the third is going to have to flip to the bottom to get rid of a negative exponent. So it's okay to have negative numbers, but it's not okay to have negative exponents. So I'm done there. All right. When it comes to I, you want to do real with real and imaginary with imaginary when you are adding and subtracting. When you are multiplying, the big thing to remember here is I times I equals I squared. So when I would do this and what I suggest on the quiz, I would write down the I chart just right above, since you know I1 is just I squared is negative 1, I cubed is negative I, and I to the fourth is 1. So that's the I1 with the negatives in the middle. All right, when it comes to 15, it looks like we have two quantities that are being multiplied, and then I'm going to subtract them. So what I'm going to do here is distribute the first two terms, and then distribute the second set. I'm going to keep this second set in a parentheses, and then we'll take care of the negative. So really what we're going to expect is just the signs to change. And again, one step at a time until we've answered the problem. So negative 4i times negative 5 is 20i. Negative 4i times negative 6i is positive 24i squared. Now when I distribute, notice that the parentheses go away. Then we're going to drop down our minus sign there, and I'm going to keep whatever we distribute here in a parentheses because I know I haven't dealt with the minus yet. 4i times 8 is 32i, and 4i times 5i is 20i squared. All right, one thing I'm going to do first is get rid of the I squareds. So this I squared I know technically equals negative 1, so it changes the sign of the term in front. Same thing with this I squared. I'm going to cross them out and change the positive 20 to a negative 20. So now I've got 20i minus 24 minus parentheses 32i minus 20. Now I'm going to distribute that negative so I can get rid of that parentheses. So all it's going to do there is change the signs. So 20i minus 24 minus 32i plus 20. Now we want to do real with real and imaginary with imaginary. So negative 24 plus 20 gives me negative 4. 20i minus 32i gives me negative 12i. My final answer, negative 4 minus 12i, because that's in standard form, real term first, imaginary term second. On number 16, don't be intimidated that it's 3 terms. Here you're just going to distribute the first 2 terms, bring them down. You're going to bring down the last parentheses and then distribute one more time. So essentially just 2 layers of distributing. And you guys are good at distributing, you can handle it. All right, on 17, if I'm just foiling with I, the only thing I need to remember is I squared. So 4 times 3 is 12. 4 times 8i, 32i. 7i times 3, 21i. 7i times 8i, 56i squared. So the only thing to remember with foiling is I times I always equals I squared. So the I squared is going to cross out, and we're going to change the sign in front. And again, the reason I'm doing that is because I squared technically equals a negative 1, and negative 1 times 56 does give me negative 56. It's a little bit of a shortcut there. All right, 12 minus 56 is going to be our real terms. And 32i and 21i are going to be our imaginary terms. I'm going to give you a second to add those together. All right, so 12 minus 56 is negative 44, and 32 plus 21 is our 53i. So real with real, imaginary with imaginary. All right, last thing that's very similar to what we did on the front side with the radicals is how to get rid of I in the denominator, and we're going to multiply by the conjugate. So pretty much, guys, whenever you see these divide questions, your go-to is to multiply by the conjugate. So just to remind you, the conjugate is the opposite of the middle sign. I'm going to go ahead and put parentheses around these groups so that it indicates to me FOIL. And FOIL stands for first, outer, inner, last, FOIL, FOIL. Corny, but we remember it. All right, negative 1 times negative 5 is 5. Negative 1 times 3i is negative 3i. Negative 8i times negative 5 is positive 40i. Negative 8i times 3i is negative 24i squared. Right? All of that is going to be over negative 5 times negative 5, which is 25. And remember, when we multiply by the conjugate, the whole point is to get I to go away, and always the middle terms will cancel. So negative 5 times 3i is negative 15i. Negative 3i times negative 5 is positive 15i. So as you guys see right there, those will cancel as they're supposed to. And lastly, negative 3i times positive 3i is negative 9i squared. Well, now what we want to do is take care of those I squareds. So I squared always equals negative 1. So cross it out and change the sign in front. Cross it out, change the sign in front. That will always happen because we're multiplying a number by a negative, which always changes its sign. The other thing we're going to do is add our real terms together and our imaginary terms together. So 5 plus 24 is 29. 40i minus 3i is 37i. All over 25 plus 9, which is 34. Now, can you think of anything that goes into 29, 37, and 34? Neither can I, which means we're done. And that is our final answer. All right, guys, I hope this has been helpful. If y'all have any questions, please contact me on Edmodo, or you are always welcome to come by room 1209 before or after school to get some help. All right, see y'all and good luck.